In this video, we're going to be looking at the fundamental theorem of calculus. Now, you have to remember what we're trying to do in calculus. All right, the first part of calculus is called differential calculus, and in differential calculus, we're trying to find slopes of curves. And in the second part of calculus, which is integral calculus, we're trying to find the area between the curve and the x-axis. Okay, so that's what we're trying to do. All right, so let's go ahead and look at the objective for this video. So I'm hoping that you'll be able to set up an integral that represents the area underneath the curve. I'm hoping that you'll be able to state the fundamental theorem of calculus, evaluate an integral by applying the fundamental theorem of calculus, and most importantly, differentiate between area and integrals. All right, there's a lot of confusion, between students between what an area is and an integral. Sometimes they're identical and sometimes they're not, and I'm hoping this video will clear that up. Now, what's the fundamental theorem of calculus? Let's pretend that you're given a function f of x that's continuous on AB, and what we want is capital F to represent the antiderivative. And if you're wondering what's the antiderivative, there's a video that you can go back and look at the antiderivative. So capital F is the antiderivative of little f on AB. Then the area can be expressed as the integral from a to b of f of x dx. But then what we're going to do here is we're going to do the antiderivative of the function. Okay, and the antiderivative of little f of x is going to be capital F and capital F. Now what we're going to do is that we have two bounds. So we have the top bound and the bottom bound. So we're going to go f of b minus f of a. So we're going to substitute the top bound into the antiderivative. We're going to substitute the bottom bound into the antiderivative, and then we're going to subtract them. And that's going to give us the area between the curve and the x-axis. All right? Now, what you need to understand is, if I gave you a function, here's f of x, and right here, Mr. Quintana, this is 1 and this is 3. We have the area here between 1 and 3 here can be expressed as the integral from 1 to 3 of f of x dx. But please understand that I could have also done something like this. Okay, here is my function, that's f of x, and it's still going to be from 1 to 3, but if you notice now, the area between them is above the curve because it's between the curve and the x-axis. Now, this is still area. However, when I integrate from 1 to 3 of f of x dx, what's going to happen is, since my function here is all negatives, what happens when I substitute a 3 and a 1? I'm plugging in a 3 into my x values, but I'm going to be getting negatives. So when I subtract negatives, I'm going to end up with a negative. So this is going to end up with a negative answer. All right? So what you need to understand is that area is always considered to be positive, but the integral is going to be positive or negative depending on where the area is located. If the area is located above the function and the x-axis, so if you notice the function is on the bottom here, that integral is going to be negative. But if you have this one up here where the area is between the function but it's above the x-axis, it's going to be considered positive. Now, a relationship that you can always relate it to is speed and velocity. What you need to understand is that speed is always what? It's always positive. It's how fast you're going. But velocity is also a speed. But what happens if you're going in the negative direction? If you're going left or down, you're going in a negative direction. So that will be negative speed. If you're going in the positive or you're going up, if you're going to the right, it'll be speed, right? It'll be speed by itself. So integral can be both positive or negative, while area is always considered to be positive. So let's look at three pictures here. So if you notice on this one here, I have this right here and this right here, and this is located where? It's located above the function but below the x-axis. So this here is going to have positive area. All of these three pictures are going to have positive area. However, this one is going to have, if I was to do the fundamental theorem of calculus, is going to give me a negative integral. A negative integral. All right? So if I was to do this one on the fundamental theorem of calculus, this part here will be positive. This part here will be positive. So what happens when I add positive to positives? I'm going to get a positive integral. But I'm also going to have a positive area. All right? Positive integral. Now, here's the kicker though. Okay? On this one, if I was to say, do you see area? And you're going to say, yes, sir, I see area. I see area right here. And I see area right here. So if I was to add those areas, it's going to be some number, right? But if I was to integrate it, here's the kicker here on this one. If I do the integral from -2 to 2 of this function, guess what this is going to give me? It's going to give me 0. What's going to happen is this here, when I substitute this one, I'm going to get a positive. When I substitute this bound, it's going to give me a negative. And what they're going to do is they're going to cancel each other out. So you're going to have a 0 integral. So the question is, if I ask for area, okay, and we know that area is always positive, how do I figure that out, sir? And I don't want to be able to cancel this out. Well, there's a shortcut. There's an easy way to always find area for all three scenarios. And what you're going to do is you're going to do the following. If you only want area, not the integrals, you're going to notice that you're going to put an absolute value around the function. So whatever the function was, you put an absolute value. And what that is going to do is that it's going to convert. Now this picture here is down here in the bottom, right? When I put an absolute value on it, it's going to make it go like this. So then when I do the integration, it's going to give me this piece and this piece, and it's going to add those up, and it's going to give me positive answer. So you're going to convert this guy to this guy if you put an absolute value. Now, what happens if I put an absolute value on this one? If I put an absolute value on this one, this guy is going to stay the same, but this bottom picture is going to be flipped over like this. So now what we're going to see is we're going to see a positive here and a positive here, so it's going to add them up. So the shortcut is to add an absolute value if they're asking you to give the area. Now, if I says find me the integral, then you're gonna give me 0 or a negative answer. So let's go ahead and apply the fundamental theorem of calculus. So let's do the antiderivative of 5x squared. I'm going to add 1 to my power. It becomes 3. And then I divide by my new power. And then if you notice, I'm putting the bar on the right side. Why am I putting it on the right side? I don't want to get it confused with this integral. All right? Because some people can say, hey, don't you integrate it, sir? Well, I just did. And if you notice, it doesn't have the little curls at the ends. All right? So now the fundamental theorem of calculus says you're going to take the 2, plug it in. So I'm going to have 5 times 2 to the third over 3 minus, now I'm going to take the 1 and plug it in. So I'm going to get 5, 1 to the third over 3. And that's going to give me 2, 4, 8 times 4 times 5 is 40. 40 thirds minus 5 thirds. And my answer is going to be 35 thirds. So this is going to be a positive. So that means that the area is going to be above the x-axis, or most of the area is going to be above the x-axis. So now this next one, find me the integral from 0 to pi of cosine of x. So what's the antiderivative of cosine? Well, the derivative of what is cosine? It's going to be sine. Sine of x from 0 to pi. I plug in the top bounds, the sine of pi minus the sine of 0. All right, so if I was to do a unit circle here, here is 0. That's going to be negative 1 positive 1 comma 0, and then over here is going to be negative 1 comma 0. So the sine of pi will be 0, and the sine of 0 will be 0. 0 minus 0 is 0. Okay, so if I was to graph the cosine of x, the cosine of x from 0 to pi is going to be from here to here. So look what's going to happen. if we were to plug this in the calculator, it's going to take this and it's going to give me what? Positive integral, but then this guy here is going to cancel that part out, and that's how we end up with 0. All right, let's look at one more scenario. Let's look at the integral of this. Well, the integral of that is going to be the ln, and we must put absolute value of x plus 1 divided by the derivative of x plus 1, which is 1. I don't worry about that. From 0 to 1. And remember, we add the absolute value because if I don't add it, that means that it doesn't exist on the left side of the y-axis, but it does. Okay, so let's substitute the 1. I'm going to get ln of 1 plus 1 minus the ln of 0 plus 1. That's going to give me the natural log of 2 minus the natural log of 1. And the natural log of 1 is 0, so my answer is going to be ln of 2. Okay? Now, on the next slide, you're going to notice that I did 3 of them. I did 3 fundamental theorem of calculus. And what I did was I also included the visuals that correspond to each integral. So what I did was I did the antiderivative of this function, which is x to the third minus 4x. I substituted the 2 on top and the, oops, and this is supposed to be a negative 2 here, a negative 2 on the bottom. So when I do that, it ends up with 0. So if you look at this, if I integrated this part right here, oops, let me change my color. This part right here is actually, and plus this part right here, are going to cancel out this part right here. So they cancel each other out, and that's how we get 0. Okay. This one we did it previously on the previous picture, and I did the picture, and it's not as nice as this one. So what's going to happen is this area is positive because it's above the x-axis, and this area is negative, and they're identical. So we're actually going to cancel these out. Okay. So this is positive area, and this is negative area. And of course, area doesn't exist as negative, but I'm saying that. And in this scenario, if we notice the function is below the x-axis from 0 to 2. So when I integrate it, I end up with a negative integral, meaning that the area is going to be more, the area is below it. All right. So let's try 2 more. Let's look at this problem. Now, on this problem, when I give you a function 5, you're going to graph. How do you graph y equals 5? You're going to go up 5, 1, 2, 3, 4, 5. You're going to go straight across, and you're going to find the area from 3. Here's 3 all the way to 7. 7, and there's 7. 3 to 7. So you're trying to find me the area from 3 to 7. So what is this integral going to be? That integral is going to be, some of you can say, I'm going to use geometry. Well, how much is that? That one's going to be 4, and the height is 5. 4 times 5 is 20. But if not, you can apply the fundamental theorem of calculus. What's the antiderivative of 5? It's going to be 5x from 3 to 7. We substitute the 7. That's going to give me 35 minus 3 times 5, 15. 35 minus 15 is 20. So later on in the next video, I'll be doing properties. And here's what you need to understand, that there's a property that says if I do the integral from a to b of any number, that means it's just going to be the number times b minus a. And this proves it right here. Okay, this shows it. Doesn't prove it, it just shows it. So what about this one here? So I'm going to integrate that. That's going to be 5x squared over 2 plus 7x from 0 to 4. And now let's plug in the 4. You're going to get 5 times 4 squared over 2 plus 7 times 4. Now that, we're going to go minus, and now I substitute the 0. 5 times 0 squared over 2 plus 7 times 0. And that's going to, all of this is just going to be a big fat 0. So here I'm going to get 16 divided by 2 is 8 times 5 is 40. 40 plus 28 is going to give me 68. And I have an area of 68. And that's it. That concludes the fundamental theorem of calculus.